Assalamu alaikum students. Lastly, we have read about the work done, what is work, and we have read about the dot product that work is a scalar quantity and it is expressed as the dot product of two vectors, and those vectors are one is the force and second is that is the displacement, or you can place it right like this F as cos of theta. So work done depends upon the force, it depends upon the displacement, and besides that it depends upon the angle between S as well as F. If this is F and this is S, then it is going to depend upon this very theta. So depending upon the theta, depending upon the nature of work done in different situations where we can have work as a positive, negative and zero work. As we are aware that now W is equal to F into S. Now first we will define, we are aware that W is equal to F dot S, or it's Fs cos of theta. First we will define the positive work. What is positive work? If I will say if theta equals to 0 degree, then once it is 0 degree, then if from this video diagram, if you are going to check it out, theta, once I'm going to say 0, then F and S both are in the same direction. If theta is equal to 0, then force and displacement, then force and displacement are in the same direction. Once they are in same direction, then I can say like this, then this very equation becomes as W, that is the work done, equals to F S cos of 0, but cos 0 equals to 1, as you are aware, then it is simply Fs. And this type of work done is said to be as positive work done. For example, if you want an example, if this is a box here, it is of some mass m, and you are going to apply force on it, and if it is going to go displaced, like it will reach here, there is no change in the mass is going to remain same, but this is the displacement and this is force. So as force and displacement both are in the same direction, then you can say the maximum work is done. For example, when a body falls, if we are having this as a body and it falls under the effect of gravity, then work done by gravitational force is positive, because at that very time F as well as displacement both are in the same direction. Or you will take what, if you are having a spring, once you are going to stretch a spring, if we are having a spring like this, and now if we are gonna stretch it out, then F and S, they are in the same direction, then work done is said to be as positive. These are the situations in which we can say there is positive work. Or in a tug of war, the work done by winning team, that is a positive work. So now after this we should have another type of work that's called as what? Zero work. What is zero work? Again, we know W is equal to F S cos of theta. Now this whole should become a zero. This can become zero only if, that is if either F is equal to 0 or S is equal to 0, or there is F but they are at, or if theta equals to 90 degree. Because if theta is 90 degree, then you can say W equals to F S cos of 90 degree, and cos 90 degree is simply 0, then it will become as 0. That's called as a zero work. So work done will be 0 when either force is 0 or either S is 0, or there is presence of F, there is presence of S, but they are at an angle of 90 degree, then that is called as what? Then that is called as zero work done. For example, if you are having a box here, this is a box, and you are going to move it like this, but there is the gravitational force that's acting downwards. So the angle between gravitational force F, gravity, and this is S. As it is not moving like this, I am pushing it. This is the applied force F, applied. This is applied force in this very direction, so that the box is moving like this. This is the displacement, but I will say the work done by applied force is positive, because both applied force and S, they are in the same direction. But the work done by, which is called as the gravitation force, the force due to earth, that is the zero. Same case, if you are having a briefcase in your hand, you are moving like this. This is the displacement, but this is the force of gravity. The work done by gravity is again zero. Or if a person takes something on his head, a coolie takes some luggage on his head, the work done by, no work is done in physics, although the load is very much heavy, but in physics no work is done. Then there is the last type of work done, that is called as what? Negative work done. Negative. By negative you have to see then as W is equal to Fs cos of theta. If this very whole term comes out to be negative, if W equals to this very minus, so that is only possible if if theta equals to 180 degree, because that means if force is in this very direction and displacement in this very, if this is S and this is F, or here will be the F, here will be the S. I will make you understand from this very example where is there negative work. If this is the box, you are going to apply force and it's going to move like this, and it's going to reach here. The gravity is going to go like this, but there is a frictional force which is acting like this. Although this is F frictional, so the work done by applied force is positive as the box moves here, but the work done by gravitational force, that is zero, as the gravitational displacement there at an angle of 90 degree. But the work done by frictional force is negative, because frictional force is in this very direction, but displacement is in this very direction. Once you are going to throw a ball upwards, the work done by, this is the ball and you are going to throw it upwards, the work done by applied force is positive, but the work done by gravitational force is negative, because constantly this applied force applied, but downwards it is gravity force, which is opposite to the applied. So they are opposite to each other, hence there is zero work done by the gravitation force. This is all for today. Tomorrow will be another lecture. Till then, Allah Hafiz.